Yep. Good evening, everyone. Sunny Camps, let's start off. Just give me a minute. So last class we are doing the position vector. Perfect. Okay. Others, Venkatesh, come on. Yasha. Hope everyone went through the notes. I'll be sending you an assignment on vectors today. After today's class, you'll be able to do a little more. Last class was just a basic stuff. So last thing we were doing was parallel vectors. Right? Then we have other type of vectors. We have something called equal vectors. This is nothing but two vectors of same magnitude and direction. And then we have zero vector. It's a vector with zero magnitude and undefined direction. So basically for a zero vector, you can assume every direction is possible. Now these are fine. Now out of all these types of vectors, right, the next one is the most important one. This comes a lot, especially in rotation and circular motion and everything. We call it a pseudo vector. You know the meaning of word pseudo? Pseudo means false. Okay. Others, you need to keep your cams on. Venkatesh, Yasha. Anyone has any doubts or anything, please always unmute your mic and you can discuss. Don't hesitate. You're still feeling shy.
Like undefined and arbitrary means the same, right? Because arbitrary.
Yeah, arbitrary meaning you're taking any direction. Undefined means the same thing. You can't define any particular direction.
Okay.
So kind of, they end of the day they mean the same in this case. Right? Palaksh, I can't see you. All I can see is your hair. Venkatesh, same with you. Just make sure I can see your full face, everyone. Keep this in mind. Every class, you have to make sure the cam, I can see your full face. Right? Niranjan, please keep your cam on. Now, what is this pseudo vector actually? Remember last class I was telling you, vectors is a chapter which was actually created. Fundamentally, vectors is not any fundamental chapter, but it is a chapter created by, especially, physics people, right? In order to define things much better. So the pseudo vector is also created in a way because it is convenient. A pseudo vector, it does not give us the actual direction. But gives a sense of rotation. I'll give you some examples. So we find the direction using the right hand thumb rule. What is this problem actually? What is the pseudo vector? Why do we need to define this? Niranjan, your cam is completely blank, right? Now, the reason to define this, look at this example here. Consider we have a particle going in a circle. With a constant speed u. we observe the direction of this, continuously keeps on changing. You observe the direction changes at every instant. So for example, if you're going in a circle, when you're here, you're going up. When you're here at an angle, when you're here, you're going left, you're going somewhere, you're going down like this, going right. If you see at every instant, right, you have a different directions. Here it is j cap, here it is minus I cap, here it is minus j cap, here it is plus I cap. You're getting this? So every instant you have, different directions. So this is actually a concern, like, it just becomes too cumbersome, like, to figure out. If someone asks you what's the direction of this particle, it is very difficult to say, like, what will you say? It is changing with time. So what do we do for this? So we created something called, the pseudo vector. So this is what we do. We will be using a right hand. So by using right hand rule, we take the curl of the fingers. Don't worry, I'll give you some examples. We take curl of the fingers as rotation. So basically you have to make a fist, and the thumb gives us the direction. First of all, again, listen what I'm trying to say. So if a particle is going on a circle, especially when things go in circles, it creates a problem for us. Every instant the direction is changing continuously. So I can't define them with a single vector. So people said, yeah, we need to do something about this. It is pretty inconvenient. Let us define a single vector somehow, even though it is wrong. That's why we call it a false vector. So what we do here, we use a right hand rule. We're going to use a lot in magnetism and circular motion. I think in school you studied something called Fleming's left-hand rule or something.
Yes, sir.
Yeah, something similar. So here, what we are doing, right? This is your rotation, and this is your direction. So, meaning, example, if a body is going in a circle like this, let's say it is 2 revolutions per second. So how do you define with the direction? So what people defined, right? Look at this thing. If you take your hand and put it on a paper and rotate it, how will the thumb point? Just imagine on your table. Don't do it on the screen. On the table, if you put a circle and if you rotate it, how does the thumb point? Out of the plane, right? Out of the paper, isn't it? So it comes out of the plane. So this meaning the dot indicates out of the plane. We also call this thing as, so we say this is 2 revolutions per second k cap. Out of the plane is k cap. Are you getting this? The best example is, what is this? Your water bottle. Look at my screen, my video. Right? You can see the water bottle. So if you see, right, most of the things that you have in the house, right, most of the things are made for right-handers. Are there any left-handers here? Do we have any left-handers in the class? Okay, we have Mehan is a left-hander. Okay. Now see, so if you see, right, most of the things that we have in the house, right, are right-hand screws. Meaning, look at this. Now you want the bottle cap to come out. Okay. So take your hand. So you want the thumb to be pointing out. Okay. Because you want the bottle cap to come out. So how should I rotate? This way. So if I rotate it this way, the cap comes out. Suppose if you want the cap to go inside, did you ever have a confusion when you're opening a bolt or a screw, like, you're confused which way to rotate? So if you want this to go inside, which way it should go? Down, right? So put your thumb down. Able to see this? So how should you rotate? Look at my fingers here. I have to make a fist, right? Like this. How should I rotate? This way, no? So I have to rotate it this way. The cap goes inside. Making sense? So the rotation of this cap, if you see, right, the cap is actually rotating in the plane, but the direction is in and out, right? Up and down. You're getting it? Is this clear? Everyone getting it? So if you see, right, not only this bottle cap, you look at your water car tap, any screwdriver, anything that you see, right, all are right-hand screws. Getting it? But there is one thing which is not a right-hand screw. Ever seen your whiteboard marker, Camlin marker? You try that, okay? Camlin marker, it's a left-hand screw. Means if you actually try to use this thing, it actually becomes tight. That screw has a left screw ka threading. Your Camlin marker is a left-hand screw. So that is the best example of, because the reason is you don't want to open the marker every time, isn't it? So they keep it in a reverse for that. So, but remaining things, right? Everything that you see, bottle ka cap, water tap, all this stuff that you're seeing are right-hand screws. So the concept is based on this. So whenever you rotate, so here, the particle goes in XY plane. So this is what I'm assuming here. This is X, this is Y, this is Z. So here particle goes in XY plane, but we are saying the direction is out of the plane. But we say direction is along Z. That's why we call it a pseudo vector. Therefore, we call it a pseudo vector. Because it's not a real direction. It is just for convenience. So what is the convenience here? Just by giving one direction, I can eliminate all that infinite directions, right? You're getting it? So let me give one more example. Is this page clear, everyone? Hope everyone is getting the meaning of a pseudo vector. So right now your fan is rotating, right? Can you tell me the direction of your fan? How is the fan rotating? The fan is rotating. So put your hand like this. So try to rotate your fingers in the direction of the fan. The thumb is pointing which way? Down, right? Isn't it? Right hand, use your right hand. So the thumb is pointing down. So for example, if you use the ceiling fan, and if your fan is rotating like this, so we define the direction is actually this way, the pseudo vector. Fan rotates in XY plane. Got this? So if I give one more example like this, let's say a body rotates three revolutions per second, J cap. Can you tell me how is this rotating? Five revolutions per second minus I cap. So what should we do here? Put your thumb along J cap. Put your thumb along J cap and curl your fingers. Basically make a fist. The rotation of the fingers gives the the motion of the particle. I hope everyone is getting the logic there. So how does this look like? So this is X, this is Y, and this is Z. So put your thumb along the Z. So you're putting your thumb like this. And if you try to rotate your fingers, that doesn't look like hand, but when you make it rotated, so your rotation is happening which way? This way, right? Able to visualize that? Anyone has a doubt on this, please ask. So just have an idea about pseudo vector, but because this thing, right, we will deal a lot.
Why we draw the downward arrow?
Where for the fan?
Yeah.
I think I took the rotations reverse. My mistake. Better?
Yeah.
I wrote for the fan wrong. What about, can you tell me how will this guy look like? Can you try? Try. I'll give you 10-15 seconds, then I'll show you. So you have to put your thumb along minus x-axis and rotate your fingers. Use the right hand. But this thing, right, extensively we will be studying in rotational mechanics. That is the first time you'll encounter this circular motion also a bit, but rotation mechanics we will deal with that a lot.
Sir, can you again show the definition of pseudo vector?
It is actually the definition. This thing you're saying, it is more of a generic definition, right? It is not a technical one, but have a look at it.
Yes, sir.
So here what we do, this is X, this is Y, this is Z. So put your thumb in this direction and your fingers when you curl them. So this is how it rotates, no? Able to visualize? So put your thumb that way. I think I wrote reverse this thing. So this is going down here. This is coming up here. Fair? I hope everyone clear with this. So this, right, you will see it everywhere actually. This right hand
I have
screw.
a question.
Bolo na.
Sir, like if there is a question, A vector points downwards and B
Right.
vector points towards east. Then the cross product of A vector and B vector will point along which direction?
That's a cross product, right? We still didn't do.
But that will be using right hand thumb rule only, na?
We can use that only, na? If you're saying you want to go from upward to east, right?
A vector towards downwards and B vector towards east.
So I hope, first of all, east is this, north is this,
Yeah.
west is this, south is this, and down is this.
Yeah.
Okay. So the down vector is going towards, so you're rotating like this now.
Like this, na?
Like this now. This vector is going like this, right?
Yeah.
It is rotating like this now.
Sir,
So
but
this
if
will be
the
like this,
B
isn't
vector,
it?
but if B vector points along east, then it will be from east to south, no?
Yeah, that's what I'm asking. It's a cross product, Ray. If you do D cross E, then this is the answer. E cross D, that is reverse is the answer.
Oh.
You have to tell me who is rotating towards whom.
A vector cross B vector.
So who is A and who is B here?
South towards south and east.
This is not south. See, I think you're getting confused between south and down. See, Mehan, there are 6 directions. In front of you is north. In front of you is north. Behind you is south. Right is east. Left is west. Up and down.
Oh.
Down is not south.
Okay.
No, that is where you're getting confused. South and down are not same. South is your, south is behind you. Down is your floor. I hope everyone is clear with that. There are 6 directions, right? It is not 4. Because I have seen people thinking like, it is because of your, the map, I guess. You think this is north and south, you think this is up.
Yeah.
No, up is actually out of the earth, right? Going into the space is up. Going into the earth is down. So there are 6 directions. Don't forget that. Have a look at this, people. Anyone has a doubt on this? All clear with this? Great. So this guy is rotating in which plane? This is rotating in YZ plane. This is rotates in XZ plane. This thing rotates in which plane is this? YZ plane. Got this? So you're rotating in a different plane, but your direction is perpendicular to the plane. I hope everyone is clear with the pseudo vector. So there is really not much on this. You just have to have a basic idea like what is it exactly. The reason why we call it a pseudo vector is because of this. It is not the actual direction. Clear? Can I go ahead? Paraksh, Niranjan, clear? Maulika? Speed is nothing, right? Normally, you say na 4 rotations, 5 rotations. So magnitude is this, the direction is this, right? So that. So I'm just giving something like it is like you're traveling 20 kilometers per hour east. Here we are more interested in the direction. The next one. Addition and subtraction of vectors. Now this, like I said last time, the resolving of vector we're going to do today. That's the most important thing in the entire chapter. The entire mechanics we will going to encounter that a lot. How to resolve a vector properly. Addition and subtraction of vectors. Idea is pretty basic. If you have two vectors, a bar, which is ax I cap plus ay j cap plus az k cap, and if you have another vector b bar, which is bx I cap plus by j cap plus bz k cap. So if you want to add the vectors a plus b, you just add the I components together. You add the y components together. You add z components together. You want to subtract them, then subtract them everything. You're getting it? So if you add them, add the x components. If you subtract them, subtract the x components. So be careful. I plus j, right, is I plus j only. It is not 2 or something. Be careful. So how to remember this thing? Tell me one thing. If I have 2 apples and if you have 3 mangoes, what do you have? You don't have 5 apple or orange, right? There's nothing like that. You still have 2 apples and 3 mangoes only. Getting the difference? I caps and j caps will never add up. They're just 2 independent quantities. So don't mix up i's and j's anytime. All i's will be together, j's will be together, k caps will be together. If you just want to add this vector, you can just, whenever it is plus, add all of them. If it is minus, just subtract all of them. Easy logic, addition and subtraction. Clear? Next one. Resolving a vector. This is the most important one. How to resolve a vector. Concept is easy, but the applications and all, we will see that a lot. This, right, especially from laws of motion and actually kinematics. After next chapter will be calculus and then kinematics. You will encounter this thing a lot. So sometimes what happens, right? They simply give you a vector with some magnitude. They'll say like this thing. Consider a vector of magnitude a at an angle theta with the x-axis. Okay, so this is your x, this is your y. So you're telling me we have a vector like this of magnitude a and angle theta. Now this is not wrong. You can simply say vector is a and theta, but this is not in a very usable format actually. So what we do for this, we can write this thing as, listen to this thing. It is like saying, where is your house? You will say, sir, my house is here at an angle theta. But if I ask you how to go to your house, what will you say? Sir, from here, walk straight along the road, then take a right turn and go here, you'll reach my house. Isn't this how we normally give the address? Go in the 4th street, right? And then go there and everything. So this will be, how much is this? This is your adjacent side, x and y. So basically this coordinates are x comma y. So we simply write the vector OA bar, which is nothing but a bar is xi plus yj. So what is x here? Sine theta is y by a. Now you need to remember this thing. Every time you'll not resolve. Opposite will be always sine component. The one which is touching the angle, the adjacent side will be cos component. So remember this thing. Next time you should just know. So that means you can write this vector as a bar as a cos theta I cap plus a sine theta j cap. So you're writing it in the form of I cap and j cap. Got this? So basically, you can write this vector a at an angle theta is equal to, you can divide them into two perpendicular components, a cos theta and a sine theta. Is this making sense? If someone gives you a vector at an angle, you can write this thing as two perpendicular components, a cos theta and a sine theta. Both are equal. The both mean the same thing. Please have a look at this. That's it. Resolving a vector, this is the basic idea. We'll do some examples and then we'll see some applications. Any doubts on this page, please ask me. Clear? Can I go ahead? Vidyut? Venkatesh?
So just a
Palak? Palak. You guys want to make a rough notes, you can always put it down in a rough, but I'll be sending the PDF anyway. So let's focus on more problem solving and all. But certain important points, you can always put it on if you want. If there's something really important you need to mug up, I'll tell you to write it up.
done, sir.
Done, no? So we have here x, y. So we have a vector here a, which is 10, and this angle is, let's say, 60 degrees. We have another vector here, which is b, which is equal to 8, and let's make it 5, and let's say it's 37 degrees. We have another vector here, 20 root 2, making a 45 degrees. Let's call this thing c. So c is the magnitude and the angle is given. I have another vector here, d, which is, let's say, 15, and let's say it is making an angle of 53 degrees. Find the vectors a bar, b bar, c bar, and d bar. So in terms of I cap, j cap, I cap and j cap, find a bar, b bar, c bar, d bar, 2a bar minus b bar, c bar plus 2d bar. Let's get all the 6. First find a bar, b bar, c bar, d bar. I hope the diagram is clear. Find a bar, b bar, c bar, and d bar. Do you guys remember 3, 4, 5 triangle? Told you in trigonometry. For people who don't know, 37 degrees now, this is actually comes from 3, 4, 5 triangle. This is 53 degrees, this is 5. So sine 37 will be 3 by 5. Sine 53 will be 4 by 5. You can get it from there in case you forgot. I'll draw a bigger one. 3, 4, 5 triangle. This is 37. And this is 53. So you should know 37 and 53 ka values. 30, 37, 45, 53, 60, 90, 120, 135. Basic, these are the things. You should know them. Anyway, maths will teach you, but physics mein 37 and 53 are quite common. Try. I'll give you 2 minutes. Get a bar, b bar, c bar, and d bar. Everyone should try. It is totally fine if you mess up the answer, but try. When I show you, you can verify your answers. You learn by trying. Don't get worried about wrong answers. Totally acceptable. A bar is how much? 10 cos 60 I cap plus 10 sin 60 j cap. So how do we do that? Now see, sometimes right, we get confused like, sir, which one is cos, which one is sine? Don't by heart the answer. Huh? Don't by heart this thing. This is a blunder. Don't by heart this. What I want you to remember is something else. You're trying to go from here to here. How can you go? You're going this way and then you're going this way, right? Make sense? Always do that way. So this will be how much? 10 cos 60. This is how much? 10 sine 60. So therefore it is 10 cos 60, you're going along x, I cap. 10 sine 60, you're going along by j cap. Cos 60 is half. Sine 60 is, this is 5 root 3 j. Now, why I'm telling you this way, look at B ka. B mein there's a problem. Angle is given with the y-axis. So how do you go to B? You first travel up and then you travel left. Isn't that how you do that? Or you can say this is 53 degrees and then you can go like this. It doesn't matter. So now how are you traveling for B? You're traveling up, which is 5 cos 37. You're going up, remember that is j cap. Then you're going left. So that is 5 sine 37. You're going left, right? So minus I cap. Right is positive, left is negative. So if I simplify this, this will be minus 5 sine 37 is 3 by 5 I cap. I'm just shuffling it up. 5 cos 37 is 4 by 5 j cap. Minus 3 I cap plus 4 j cap. Is that making sense? This is 5 7 37. This is 5 cos 37. Please ask me if you're confused. You can leave the answer in terms of root. No need to simplify. You can't add these two. I and j will be just left over like that.
So,
Right, Malika?
so how could we write cos j cap isn't cos the x-axis?
Why bol raha Abhinav? Don't by heart it. In this case, when you take a vertical angle, for 37, who is the adjacent side? This one, right?
Yeah.
And that is pointing which direction?
Why?
So that is j cap, right?
Yes.
Are you getting my point? See,
Yeah.
there is nothing like that is cos, j and I cap. Cos and sine are simply the adjacent side and the opposite side. Now your adjacent side can be in the y direction, your adjacent side can be in the x direction. So you have to see which way it is pointing and accordingly keep I and j. Is this making sense, everyone? Anyone confused with this? Please ask me.
Shouldn't it be minus 3 j cap?
Array, it is going up, right? Plus y, na? That is plus j, right?
Yeah.
And you're going left, right? So that is a minus x axis, isn't it?
Okay.
Are you sure?
Yeah.
Here I started with j cap people and then I started with I cap. So basically what you're doing is from here, I want to go here. How will you go? First go up. How much will you go up? 5 cos 37. Then you go left. How much will you go left? 5 sin 37. Abhinav, getting that logic there, no? It is not about cos and sine. You're going up or left. What is this up ka direction? Up ka magnitude 5 cos 37. Why? Because that is the adjacent side.
So why that minus 5 there?
You're going which way? Left hand side, right?
Yeah.
That minus x axis, no? Then.
Yeah.
So that is a minus sign, no?
So not that one. I understand.
Uh-huh.
Why is it minus 5?
Where is minus 5? Array, this minus came out now.
Okay.
I just crisscross these two. Got it? I wrote it in terms of I and j.
Yeah.
Any doubts on this thing? Anyone else?
So I can show the previous page.
Yeah. What about D and C? Get them. यहाँ पे एक और question है 2a minus b bar. Let me finish off that. So 2a minus b bar is how much? 2 times a bar, that is 5i plus 5 root 3j plus b bar, that is minus 3i plus 4j का minus sign. Just multiply 10i 10 root 3j minus of minus 6i minus 4j. So this will be 16i plus 10 root 3 minus 4 j cap. Just a matter of addition there. Add all the i's and add all the j's. Check this out. All clear with this? Check this out, C and D. Get it? So you should always see which way I'm going. You know, it doesn't matter. In cos is not I cap, sine is not j cap. Cos is the adjacent side, sine is the opposite side. You see your adjacent side is going along x or y, and then accordingly you keep I and j. Anyone is still confused with that? Please ask me. It's quite important.
Can you just go back for a minute?
This thing.
Sir?
Yeah.
So how did it become 6i over there? 6i cap.
That was 3 actually. My mistake. My mistake. That was 3 actually. That was a mistake.
No, but in the B wala thing, we can also take 180 minus 53, right, for calculation.
But it'll be, why you want to do that, na? Keep it simple, right?
Okay.
Why you want to bring so much trigonometry into it? 180 minus 37 will be that angle. Sine 180 plus theta is minus sine theta. You have to do all that stuff.
Yeah.
So keep it simple, na? Take the angle and you just have to travel. That's what I'm saying. Look at this thing. So when you're traveling in C, right? Look at this thing, everyone. You are going from here to here. How should I travel? First go left. Left means what? Minus I cap. Then you're going down here along the minus y axis. So how much is this magnitude? This is 20 root 2 cos 45. This is 20 root 2 sine 45. So if someone is still confused, see what I'm doing here. This is C, right?
So
in
over
order to
here,
reach-
so it won't matter, na, but because both the values will
like-
come the same.
Yeah, but doesn't matter. But we have to be clear, na?
हाँ.
So that 20 root 2 cos 45 kitna hoga? 20, and this is 20. Now, Abhinav, see this thing. Now, from this point, you want to reach this point. How are you traveling? You're traveling 20 left, and you're traveling 20 down. So what will be C bar here? Minus 20 I cap, minus 20 J cap. Does that make sense?
Yes.
It is not about cos theta, sin theta. It's not about that. You have to travel 20 meters on the negative x-axis. That's the reason you're getting a minus sign. And you're traveling 20 meters along the negative y-axis. That's you're getting a minus sign. Please check this thing, everyone. The resolution of components is quite important. Resolution. And this thing, you travel to the right and then you travel to the down. So D bar will be D cos, that is 15 cos 53 I cap, and this will be minus 15 sin 53 J cap. Cos 53 is how much? 4 by 5. So that will be 12 I cap. And that will be 3 by, that is 4 by, this is 3 by 5. This will be 9 I cap. Sin 53 will be 4 by 5. And that will be 12 J cap. Got this? And I'm asking C bar plus 2D bar. So C bar is minus 20 and 2D will be 19. So that is minus 2 I cap and minus 20. And this is minus 24, minus 44 J cap. Check. All clear about this?
Yes, sir.
Everyone got how to resolve the components? Let's see one more. Can I turn this?
Yes, sir.
Let's see some physical situations. Actually, how do you use
1
this?
minute, can you go back?
Yeah. Who got disconnected? Someone got disconnected. Clear? Malika, clear, na? Malika, she got disconnected, I guess. Swastika, clear?
Yes, sir.
Adrit, clear?
So that's 44.
Yes.
44.
Yes, sir. Done.
नहीं दिख रहा क्या ऐसा? I know. 44. Happy? Next one, say. Let's say we have an incline like this, and we got a block here. Don't worry about the situation. Let's say it is 10 kg. So the weight vector mg is 100 newtons. So generally what we do, right? We treat this as x-axis and we treat this line as y-axis. You can choose any line as x and any line as y. And this angle is given as 30 degrees. Resolve the weight vector, that is mg, along x and y axis. So we got a block of 10 kg here whose weight is 100 newtons. Along the incline, you have taken x-axis, and perpendicular to the incline, you've taken it as y-axis. You can choose any line as x and any line as y-axis. The only condition is x and y should be perpendicular. So the question is, resolve this weight vector along the x-axis and along the y-axis. Get it? Easy one. This is how you'll actually see in a problem. No one will ask you directly divide a bar and b bar. Okay, see.
Sir, the 100 Newton force is perpendicular.
100 will be down, na?
Perpendicular, na?
Perpendicular matlab? Perpendicular to what?
To that
The
angle
ground.
30 degree to the ground.
Perpendicular to the ground.
Yeah.
Weight vector, na? School mein to padha hoga na? Weight will be always down only, right? Matlab, yeah. So first thing, what you need to do, get the angles, everyone. So this will be 90. So this will be how much? 60, and this will be 30. Now you can choose any angle. Which one you want to take, 60 or 30? Choose any one angle, okay? It doesn't matter. So I'll do one thing. I'll just 60, okay? So if you take 60 here, so this will be, so whichever side touches the angle is the adjacent side. So this will be your adjacent side, which is mg cos 60. The other one automatically, which does not touch, becomes the opposite side. That is how you can remember which is adjacent and which is opposite. Opposite is always mg sin 60. Is that clear? Suppose if you had taken 30, then what would have happened? This will be the adjacent side, mg cos 30, actually, which is same as sin 60, isn't it? Answers will remain same. You can choose any angle, it doesn't matter, answers will remain same. So this vector, we can write it as mg cos 60 is along the x-axis, so I cap, and mg sin 60 is along the j-axis, which is j cap. You can simply write this thing as mg by 2 along the incline, mg root 3 by 2 along the j cap. So pictorially, na, this is how we will draw actually. So if you have a weight vector mg, we can divide this into two components. This will be mg sin theta, and this will be mg cos theta. Where if you take this angle is theta, this will be theta. That's how you resolve the vectors, mg cos theta and mg sin theta. So the force which is responsible for dragging you on the incline, which component will drag you on the incline? Which component will drag you on the incline? Sine or cos? The sine component, right?
Time.
So you will slide on the incline because of the sine component. Is this fine, everyone? All got this? Go ahead. Let's see one more like this. So we have a ball stuck like this. This is theta and this is theta. So this is your x-axis and this is your y-axis, the regular x and y. So here we have two forces, huh? N1 like this, N2 like this. N1 is perpendicular to this line, N2 is perpendicular to that line. So write N1, N2 in terms of I cap, J cap. Both these angles are same, theta, theta. Able to visualize the diagram? The ball is stuck between two inclines. Resolve N1 and N2. Anyone confused with the diagram, please ask me. If you see, the main thing is getting the angles proper. How do we resolve this? I'll help you for one, N1. Let's take this N1 guy, okay? So whenever you get this thing, right, the idea is extend this guy, extend this line. If I extend this line, what will be this angle here? 90 minus theta, agreed? All got that? So that means what you got is a vector from x-axis where the N1 is looking like this. Okay. I can take this angle theta, 90 minus theta. You take whatever you want. I will take theta for convenience. So what are the components? The vertical component. No, this is the adjacent side. Remember, whichever side the angle touches is the adjacent side. N1 cos theta. Automatically, this side will be N1 sin theta. So you can write N1 bar is minus N1 sin theta I cap and N1 cos theta J cap. You can just leave it like that. Sure, what we did? So whenever you have to resolve something, right, the main idea in this question is somehow using geometry, get the angle between the vector and the x-axis and y-axis. If you get the angle, your job's done. Can you try for N2? But any doubts on this, please ask. N2 is this guy. Try for N2. I'll give another minute. Anyone confused with N1, please ask. This is how we need actually this resolution of vector in physics. We are not actually interested in the I cap, J cap. That is nonsense. We are more interested in how do you actually resolve these forces. Anyone confused or not here, please ask. Just give it a try. I'll get some water and come. Let's see any answers. Okay, someone typed an answer. N2 sine, N2 cos. Sine and cos, what are the angles, Ray? Angles matter. You can just start the sine and cos. See this one. Idea is the same. So what you do this time? Extend the vector, right? If I just remove the line here, can you tell me what will be that angle now? What is this angle? 90 minus 2 theta, agreed? Because this total angle is 2 theta, no? Means what the vertical, this angle will be 2 theta. So x and y axis, this is what you have. So your vector N2 is like this. And your vector N2 is like this. And it is making an angle theta, 2 theta here. So this will be the adjacent side, N2 cos 2 theta. This will be the opposite side, N2 sin 2 theta. I hope everyone is able to see that. So therefore, N2 bar will be N2 sin 2 theta I cap minus N2 cos 2 theta j cap, because it is pointing downward. So you always have to see which way are you pointing. Is that clear, everyone? Basically, you're going like this, now you're going down and then you're going right. So this down guy is N2 cos 2 theta. Please check, ask me if you're confused.
So basically you split the vector parallel to itself, right?
Yeah, that's what you're doing, right? Because you can move the vector anywhere, right? It doesn't change.
Yeah.
Whether I keep it here or here or here, it shouldn't change the answer. Everyone got this thing? How did we use this? Check this out. Any doubts, please ask me. This is quite important. This is what I was saying. This is how we need to learn resolution of vectors. All clear? Let's go ahead. Palaksh, clear na, Vidyut?
Yes, sir.
So we are going ahead. Next one. Now we will do a concept called equilibrium. We have done something similar in foundation, but yeah. What do you mean by equilibrium? If sum of the force vectors, that means on a body, let's say there are 10 forces acting. And if all the force vector cancels out, if sum of the force vectors acting on a body is a null vector or a zero vector, it is also called as null vector. The body is said to be in equilibrium. That's it, simple. What is equilibrium? All the force vectors should cancel out. Okay. So if you got a body here, and let's say we have F1 bar, if you have F2 bar, if you have F3 bar, And if you have F4 bar like this, so the sum of the 4 vectors, F1 bar plus F2 bar plus F3 bar plus F4 bar is 0. Now, the important thing here is, if you divide these vectors along I cap and J cap, the component of the forces. So all the I component should cancel out, all the Y component should cancel out, all the Z component should cancel out. The component of forces in any direction cancel out. Have a look at this.
So, but this will be only if the angle between all of them are equal, right?
Not necessary, no? Not necessary. I can change the magnitudes also, right?
Oh, right.
I can adjust the magnitudes and the angles, so I can get infinite possibilities.
So, but if it's equal, all are equal magnitudes, then the angle has to be equal, right? Okay.
All clear with this? So let's see how to apply this. So let's say we have a body here. It is acted upon by 3 forces. F1, 10 newtons. F2, 10 newtons. Right? And we have another body here, F3, angle of 60 degrees. F3 ka magnitude is not given. So body is acted upon by 3 forces. Three forces F1, F2, and F3. So the first question, find F3, the magnitude, if the body is in equilibrium or body is at rest. The body is not moving means it is in equilibrium. Second question, find F3 if body moves along x-axis. Find F3 if the body moves along y-axis. Let's do one at a time. Let's do the first one. So there are 3 forces acting. F1 is along x-axis, F2 is along y-axis, F3 is at an angle 60 degrees with the negative x. Find the magnitude of F3 if the body is not moving. Find the magnitude of F3 if it is going along x, if it is going along y. 3 different questions. Let's try the first one. I'll give you a minute for the first one, then I'll show you.
You have to find the magnitude of F3, or you have to find that vector in terms of I and J.
No, magnitude. F3 ka magnitude. If I get the magnitude, I can find I cap, J cap anyways, right? So that is okay. Angle is given. Let's find the magnitude. Try for a minute. I'll show you. But give it a try. Rehan, I can't see you. Okay, you're there. 10. Let me show the first one. Say. How to do these kind of questions? So listen to the process. Huh?
Sir, for this, can we do lateral shifting of the vector?
You can do that, but itna chahiye nahi tha actually. See na, you already know this thing. F2 is acting which way? 10. F1 is acting which way? 10. What will be this component here? Cos or sine?
Cos.
What will be that? Cos, right? F2 cos 60. What will be this one? Sine? F3 sine 60.
Yes.
Got it? So see, I'll tell you one thing again. I cap, J cap, that is not required. This is actually better way to do. So I can directly put it in a diagram. F3 cos 60 and F3 sine 60. Does this make sense?
Yes, sir.
Huh, Niranjan, is this making sense? So I can, instead of writing ij cap, which is actually cumbersome, let's keep it in the form of a diagram only. Maulika, clear, no? Now you want this to be at rest. So what should happen? For this to be at rest, along the x-axis, they should cancel out. So your F3 cos 60 should be equal to 10. Agreed? So what is the answer here then? This is F3 is 20. This is the condition for what? If this is satisfied, body won't move along x-axis. If the force along x-axis is 0, you won't move along x-axis. In order to move in a particular direction, you need a force. If you take y-axis, F3 sine 60 should be equal to 10. Sine 60 is root 3 by 2. So F3 is 20 by root 3. So this guy is saying, if you give me 20 by root 3, body won't move along y-axis. What is the meaning of this?
It is not possible to get both of them together.
It is not possible to get both of them. Na? Are you getting it? If you try to satisfy x direction, y is not getting satisfied. If you try to satisfy y, x is not getting satisfied. What is the meaning of this? The body can never be at rest. Are you getting the answer? Just because the question is given doesn't mean there'll be an answer. So if you see here, it is not possible to be at rest along x and y at the same time because you're getting two values. How can F3 be 20 and 20 by root 3 at the same time? It is not possible for F3 to have two values at the same time. That is, if it is at rest along x-axis, it has to move along y-axis. Then it should move along y-axis. Got it? So what is the answer? Therefore, body can never be at rest. There is no answer. You can't find a value of F3 which will satisfy. Is that clear, everyone?
Sir, can it be root 10, root 2?
Root 10, root 2. How did you get that?
Sir, we will use a triangle law of addition.
किसको triangle law करोगे?
So vector F1, we can shift it perpendicular to F2, then we
Shift
will...
ना, then what will you get? Then you'll get 10 root 2 ना?
Yes.
But angle कितना होगा? 45 ना?
All right.
But आपका angle ये 60 है ना? इसीलिए conditions cancel नहीं हो रहा था. You're getting it?
Yes, sir.
Both are not in the same direction only ना? कुछ भी करो, it will not cancel, right? I hope everyone is getting the logic here. What Palaksh is saying is, sir, 10 and 10 ko magnitude is 10 root 2. Agreed. But what is this angle? 45 degree. Your F3 is at what angle? 60 degree. Can they ever cancel out? They're not opposite, right? They can never cancel out. That's why you're not getting an answer. I hope this was clear, everyone. Decent question. Question is still not over. What is the answer for these two then? If you want to go along x-axis, if you want to go along the y-axis. Actually, answer आ गया था यहाँ पे.
We can take either for the, like, we can take 20 by root 3 for the second one and Sure.
Yeah. So if you want to move along, x-axis, what should happen? You should not move in y-axis, no? So if you want to move along y-axis, it should not move along x. So f3 should be equal to 20. This is the second part of the answer. So if f3 is 20, you won't move along x-axis. It implies you're moving along y-axis. To move along x-axis means you should not move along y-axis. f3 equal to 20 by root 3. I hope this was clear. You can't be at rest. Either you go along x or you go along y. One of them has to go. Please check this out. Any doubts, please ask me. Ajit, clear, na? Maulika, Rehan, Mehan, clear?
Yes, sir.
Anyone not convinced? Abhinav, clear?
Yes.
Swastika, got this?
So,
Perfect. Go ahead.
so
Arjun.
So in this, like, if you would have like you would have made a vector triangle, and you could have used rule of signs also, na? And then one ratio.
Naina, Arjun, you're getting confused. It won't form a triangle.
Oh,
This is
because of
10
the
and 10?
angle. Yeah, okay, understood.
Because it won't form a triangle.
Yeah.
The problem is that you will never get a triangle in this scenario.
Understood.
All clear?
Yes, sir.
Next one. I hope you're getting see how to use the resolution of forces. This is how we actually use. So more than I cap, J cap, now this is how I want you to learn. Always put it on a diagram. It is more clear and you'll get a better clarity what is happening. I cap, J caps are boring, but that is more mathematical way of representing it. In physics, this is how we use it. Let's see one more like this. We'll get the hang of it. Let's say we have a block here. And we got a string here. Let's say this is 2 kg. So this will be 20 newtons, the weight. So this string is pulling with T1 and this string is pulling with T2. Let this angle be 60 degrees. A block is tied by two strings and remains at rest. Is attached to two strings. At rest. T1 and T2 are the tensions in the string. Everyone knows now what is the tension? Force by the strings. T1 and T2 are tensions in the string. Tension is simply the force in the string basically. Find T1, T2. Mass of the block is 2 kg, weight is 20 newtons. So this is how they'll bring it. Now they'll get physical systems. And you have to see that tensions and all that stuff. This is how we actually use vectors. This is the most important thing. And I cap, J caps are okay. This has more practical applications. Try this. I'll give you a minute. Then I'll show you one how to do it. But give it a try. I'm sure. So those are in the foundation, right? We have seen something like this. Even if you're not in foundation, it is totally fine. I hope you understood how to do this. Give it a try. Anyone confused with the question? Please ask. Don't hesitate.
So is T2 and that the rigid support of T1 parallel?
These are 90s.
Okay.
Okay.
Yeah.
Any answers? 40 by root 3 and 20 by root 3. Okay.
Sir, what is tension and formula?
कुछ formula, you have to find T1, T2 रे.
Only way to find the force?
हाँ, उसका magnitude निकालना था T1, T2 का. Basically, T2 is the force by this string, F2 na. This is the force due to this string F1. So instead of calling F1, F2, we call it T1, T2 for strings, tension. It is same like previous question, na? Here I said F1, F2. And here I'm calling T1, T2. Same thing. Just the symbol is different. Aditya got 40 by root 3, 20 by root 3. That looks suspicious actually, but maybe right. Let's see. Maybe. Looks right. How to do this? So just draw a neat diagram. You will get it. So look at the forces. 20. This is T2. This is T1. If that angle is 60, this angle is 60. So this is 60. So what will be this component here? It is touching the angle, so it is adjacent side. T1 cos 60. What will be this thing here? T1 sin 60. Everyone agrees?
Yes, sir.
Since it is in equilibrium, in the x-axis, T2 should be equal to T1 cos 60. Cos 60 is half. So T2 is T1 by 2. In the vertical direction, that is the y-axis. So later on, we will not write x and y, all that. We'll directly write the equation. But okay, in the beginning, you will slowly get it. T1 cos 60 is 20. So this is T1, root 3 by 2 is 20. So T1 is 20 by root 3. Take this T1 and substitute here. This will be 20 by 2, so 10 by root 3. Check.
Sir, T1 is 40 by root 3.
40. Yeah, my mistake. So this is 20 by root 3.
By root 3.
Yeah, right, Aditya. You got it right. Yes, I also got it right. Please check how I did this. Easy, right? Just divide the forces, balance vertical, balance horizontal equations and solve. Anyone confused with this, please ask.
Sir, can you explain this again?
Did you understand this components?
Yes.
So basically equilibrium matlab kya? This and this should be equal, na?
Yes, sir.
This and this should be equal, na?
Yeah. Got it, sir.
Then that's it. Just solve it there. Anyone confused, please ask. Niranjan, clear? Venkatesh, clear? Adrit? Go ahead, next one. Next one. Similar question. We have two strings like this. This is 60. This is 30. This is 5 kg. So this is T2. This is T1 and the weight is 50 kg. System is at rest. Means it is in equilibrium. Find T1, T2. So we just change the angles a bit now. 25 and 25 root 3. And someone got 100. Okay. Aditya, you got 25 and 25 root 3. Yasha got 100 by root 3. Some one of you is wrong. Adrit also got 100 and 100 root 3. So I think Aditya, check your answer once. Two people got hundreds.
Sir, it is 100 by root 3.
Got it. It is just solving, simultaneous equations. There's nothing there. So draw the diagram. So this is T2. This is T1. So if I extend this angle will be 60. This angle will be 30. I hope everyone got that. So this angle is 60 and this angle is 30. So if you divide the components, this guy will be T2 cos 60. This guy will be T2 sin 60. This guy will be T1 cos 30. And this guy will be T1 sin 30. Anyone confused with the components, please ask. And your weight will be downward 50. Is that clear? So in the vertical direction, y-axis, these two guys are balancing the weight. So T1 sin 30 plus T2 sin 60 are balancing the 50. So unlike the previous problem here, two people are trying to balance it. And along the x-axis, the T1 cos 30 and T2 cos 60 are balancing each other. Cos 30 will be root 3 by 2. Cos 60 will be half. So we get T1 root 3 is equal to T2. So take this T2 and substitute here. This will be T1 by 2. T2 will be T1 root 3 and sin 60 is root 3 by 2 is equal to 50. That's how you solve simultaneous equation. Don't try to do all that school stuff. Take T1 from one equation or T2 from one equation, dump it in the other. This will be T1 by 2 plus T1 3 by 2 is 50. This will be 2T1 is 50. I think Aditya, you're right. T1 is 25 newtons. If T1 is 25, then T2 will be 25 root 3. Check. Yasha, Adrit, you guys got messed up. You got hundreds. Aditya was right.
So in this x-axis, how are they equal? Because the angles are different, right?
No, but the magnitude is also different, na? The magnitude T1, T2 are also different, no?
Yes, sir. So
that component should be equal. You're getting it? You can have different angles, you can have different magnitudes also, no? But the component should be equal, right?
okay.
So end of the day, what we want is these force and this force are equal. I'm not saying T1 is equal to T2 or I'm not saying cos 30 and cos 60 are equal. Hope that makes sense. Sure, no?
Yes, sir.
All clear with this? Great. Let's see similar one, but a little different model.
So can you go back for a minute? Thank you.
So here we have these things, and we have a sphere like this. The sphere got stuck like this. Okay. So this corner, now there is a force like this, N2, which is passing through the center. This corner has one more force, N1, which is again passing through the center. And this is your weight, mg. Let's say this is 100 newtons. This angle is 30. And this angle is 60. So basically a sphere is stuck between two tables like this. Find N1, N2. If you see end of the day, all the problems are similar logic. Divide the components along vertical, along horizontal, and equate them. But I hope you can see, right, the physical systems, how they look like. We can bring strings, blocks, wedges, spheres, all that stuff. So sphere of mass 10 kg. Anyone confused with the diagram, please ask. This is how we prefer to learn maths in physics. We are not exactly a maths class. We don't want all that maths class stuff. Maths people will teach you vectors for almost 3 weeks. They have a full chapter. What we are more interested in is the applications. How do you apply these vectors in physics?
The mass is 10 kg, right?
So mg weight is 100 Newton. Na? 10 into g. I'm taking g time. Anyone confused with the question, please ask. So currently in PACE, which chapter are doing?
Vectors only.
Vectors only. Where did they reach?
Today they did cross product and right hand thumb rule.
Yeah.
Yeah. So
So they finished all this resolution of vectors, all this was done.
Yeah, but the order he did it in was pura different.
So he did it in a different order.
Okay. ठीक है ना, fine. It's okay. Initially, they will slow down actually. We'll bump up after this mid or something. We will increase the duration also, and we will also go. But if you got a, did you guys get the test schedule or something? The schedule planner.
Yes, sir, we got.
Send it to me, no, after the class. Just forward it to me.
Yes, I'll send.
ठीक है? Yeah. Someone just post it in the group. Don't send me personally. Everyone will send me personally. I have 10 of the mails. Just one guy put it in the group. I will take it from there. So I'll plan according to that. Meaning it should be same as last year. But last year, what happened? Your seniors, we are having an issue because of that. Your seniors' board exams got over in May end. Your seniors' board exam got delayed by 2 months last year. So we started that course only in June. So now we are facing the pressure there actually. Luckily for you guys, we're back to April. What is the answer? Anyone? Adrit got 50 and 50 root 3. Aditya, answer? Same, okay. So I just put a point there for convenience. This is N1. This is N2. This is 100. So this angle is 60 degree. So this guy, so this is also 60 degree. So this will be N1 sine 60. This will be N1 cos 60. This angle is 30 degree. So this is the alternate angle. This is also 30 degree. This will be N2. If you're not touching the side, it is an assigned component, opposite side. The one touching is the adjacent side, N2 cos 30. So in the vertical direction, if you see, the N1 cos 60 plus the N2 cos 30 are balancing the 100. Horizontal direction, N1 sin 60 is balancing the N2 sin 30. So N1 root 3 by 2 is N2 by 2. 2 goes off. We get N2 is N1 root 3. It's actually quite similar to the previous one. Take this and dump it in this. Cos 60 is 2. N2 will be N1 root 3 by 2. Previous case, it is the strings. Here it is the walls. It is exactly the same thing if you observe the equations. This guy will be 2, N1 is 100. N1 is 50 and N2 is 50 root 3. Please check. Anyone confused here, please ask. N1 25 root 3 and 2. Palak, check your answers. Somewhere you messed up. Yeah.
So why can't we directly use trigonometry over here, like drop a perpendicular from N1 to MG? And then
Here it is easy, na? That's why. What if I give you something like this?
okay.
We still didn't reach there actually. So I'm taking it there and giving you easy ones. Once I take it little, this thing, you'll have 4 forces, you won't understand what to do.
Yeah.
All clear with this? Last one. Let's say we have a sphere like this and a wall. You're getting how it is? It is pushed. So this guy is stuck between 2 walls like this. This is N1, this is theta, and this is N2. Now we will do in variables. I'll not give you numbers. So N1 and N2 are passing through the center, and you have your own weight mg. Find N1 and N2. So basically, we got a sphere stuck between 2 surfaces. I'll be sending a sheet on similar questions like this, and maybe I'll send you some 8 to 10 on the position vector and these kind of questions. So make sure to try. We'll discuss them on Friday. Let's finish off. Last one for the day. So sphere ka weight is mg and N1 and N2. These are perpendicular. Huh? They'll be perpendicular to the walls. And they're passing through the center. Now here they're not perpendicular, na Arjun? This is nothing, right? Later on, we will do a question like this. We have 2 walls here, we have a sphere here, we have a sphere here, and we have a sphere here. 3 spheres got stuck inside them like this. So then I ask you to find the force between each sphere. Hope everyone is getting the resolution of vectors, how to use it actually. The resolving and all is easy actually. But how you apply in a problem is a more important. This is the main thing. After this, the remaining parts actually go quite fast. mg cos theta, mg tan theta. Okay, mg by cos theta and mg tan. Try. I'll give you a minute more. Answers will come in terms of mg, cos theta, and sin theta terms by angle, tan theta, whatever. You should learn how to do problems in variables. Numbers will not be given generally in advance. They do give, but you'll find questions with variables also. Learning with variables is better. That gives a better perspective. And later on, I'll teach you how to guess questions also. Like, if you see a question, how can you guess the options? Important skill. So don't mistake it. See, just because you know the subject doesn't mean you'll do the exam well. Performing in the exam and knowing a subject are two different things. Let's draw the Fosca diagram here. I'll just remove these walls for more clarity. I will just extend this guy. This will be 90 minus theta. So this will be theta. Perfect. So on this pier, you have forces N2. This is mg. And this is N1, which is making an angle theta with the vertical. So this component will be N1 cos theta. So any side touches theta is the adjacent side, cos theta. N1 sin theta. You are done. That's it. Oh yeah. So in the vertical direction, N1 cos theta is actually balancing the weight. So N1 is mg by cos theta. Like I said, drawing the diagram is the most important thing. Solving is quite easy. Horizontal direction, N1 sin theta is balancing N2. Take this guy and put it here. That will become mg sin theta by cos theta. N2 is mg tan theta. Check. Have a look at this. Just give me a minute. Yeah. All clear with this? mg by cos theta and mg tan theta. Adrit, once check, you got a sin theta.
I took theta in the reverse direction. 90
Be
minus
careful
theta
with the
equals
angles.
theta.
Yeah, just be careful with the angles, everyone. Clear with this? So you'll get a sheet like this. I'll send you by tonight or tomorrow morning. So you can try that, and Friday we will discuss that also. So Friday we'll finish off this resolution of vectors, and then next class we'll start off with parallelogram and dot product, cross product. They're not much. They'll get over fast. But this is how I want you to learn the problems, resolution of vectors. This is what is more important for us. Clear? So any doubts, anything you can stay back and ask, or else you're free to leave. Right? And next Sunday, right, we'll be having an orientation session. That is on 30th of April. Right? And we'll be getting the materials will be dispatched on May 1st or 2nd week. May 15th, you will get the books also. I'll be sending some material. Not some material, it is total around 10 books of 2000 pages total. So it will be quite heavy. So they'll come to your house directly, don't worry. No need to carry the stuff. And I'll explain you how to use the material and what kind of books you need to buy. You really don't need to buy too many books. You just get HC Verma for now and your PACE booklet, more than sufficient. For people who don't have PACE booklet, you can use my booklet. So I'll explain you all that stuff. So don't be in a hurry now. Right. So make sure to try all the problems we did today again. I'll send you a sheet. I'll put some tough problems also. So give it a try. Okay. So any doubts, anything, please stay back and ask. Also free to leave. I'll see you on Friday at the same time.
Axial vector and pseudo vector same.
Yeah.
Okay.
So,
Sir, I had a doubt in that basic math sheet too.
Yeah. I'll take up. So those are out. Stay back. Others can leave. Let's just call this thing also as axial vector. There are many names for this. Sure. Any doubts in today's class, you can ask. Also free to leave, or the doubts in the